We want to use a double integral to find the area of one petal of the rose. R equals 2 sine 3 theta. Let's remember that typically volume is the double integral over some region omega of f of x, y, dA. If we want it to be area, area is the double integral over some region of 1 dA. And then in polar coordinates, what do we have to remember? In the world of polar coordinates, the change in area is r dr d theta. So we're starting with the double integral over some region of 1 r dr d theta. So we need to determine what is r range from and what does theta range from. So let's take a look at our graph to do some analysis. So here is the graph of that rose. R starts at 0, it goes, and goes until it hits the curve. So R goes from 0 to 2 sine 3 theta. So that's not terribly challenging. So RA will be double integral R goes from 0 to 2 sine 3 theta of 1 R dr d theta. What takes a little bit of work is to determine what theta is ranging from. So I'm asking for one petal. So let's take a look at what a petal looks like here. So here's a petal. Notice the petal is at 0, it moves out, and then it comes back to 0. So the first petal is traced between values of r that equals 0. So we need to figure out when does r equal 0. So let's do a little analysis. We have r equals 2 sine 3 theta. I want to know when r equals 0. So 0 equals 2 sine 3 theta, which would mean sine of 3 theta equals 2. Excuse me, sine of 3 theta equals 0. So for which values is sine 0? Well, what do we know? We think about our unit circle, right? And sine is 0 here and here. So 3 theta could equal 0, in which case theta equals 0. Or it's also could equal pi. Yes, sine of pi is 0. So if that's the case, since sine of pi is 0, 3 theta could equal pi. So theta would be pi over 3. So it feels to me as if the first petal would be traced as theta ranges from 0 to pi over 3. But let's check our graph to see if that's the case. So right now, the computer arbitrarily chose it to go from 0 to pi. Let's change that from 0 to pi over 3. Does that give us the first petal? And sure enough, it does. So we have successfully set up the formula that we need to find the area of that petal. So let's do our analysis. So we start with this, and then of course we need to do the inner integral. And the antiderivative of r is r squared over 2. Evaluated as r goes from 0 to 2 sine 3 theta. So doing our substitution, 2 sine 3 theta squared over 2 minus 0 squared over 2. 2 squared is 4, divided by 2 is 2. Sine squared 3 theta minus 0, which then leads us to our original integral. So our area, which is the integral, will be the integral as theta goes from 0 to pi over 3 of 2 sine squared 3 theta. D theta, so that'll take a little work. Let's go ahead and do that now. So this is the integral that seems to come up so often. So let's go ahead and do our analysis, starting with a double angle identity. I'm not going to use theta here. So I'll say maybe cos 2z is cos squared z minus sine squared z. And this time I need to keep sine squared, so I'm going to use my Pythagorean identity, rewrite cos squared as 1 minus sine squared. So we get cos 2z is 1 minus sine squared z minus sine squared z. Continuing, cos 2z equals 1 minus 2 sine squared z. Bring the 2 sine squared z to the left. 2 sine squared z is 1 minus cos 2z. And then divide both sides by 2. Sine squared z is 1 minus cos 2z over 2. But we need z to be 3 theta, so let's make z into 3 theta. So sine squared 3 theta is 1 minus cos 2 times 3 theta over 2, which gives me sine squared 3 theta is 1 minus cos 6 theta over 2. That'll be our substitution for that part of the problem. So let's go ahead and make that substitution. So the substitution is done. You'll notice the 2 divided by 2 divides out. Now that we're here, we can do our antiderivatives. What are they going to be? Antiderivative of 1 d theta is theta. Antiderivative of cos 6 theta would be sine 6 theta over 6. Use a use substitution if you need to. Evaluate it as theta goes from 0 to pi over 3. So where does that put us? So we get there, which would give me area is pi over 3 minus 6 times pi over 3 is 2 pi minus sine 2 pi over 6. That stuff's all 0. And sine of 2 pi is just 0, so I get pi over 3 minus 0 equals pi over 3, which is kind of interesting. So let's go back and take a look at our graph. So the area of this petal is pi over 3, which is a little bit more than 1, and I think that seems pretty reasonable. This box is 1 by 1, so if we take this amount and this amount, that's a little bit more, I would say, than those two pieces. So geometrically, that seems reasonable.